Hello all, I'm Developer Ali and I am a developer advocate here at the Filecoin Foundation. The accent is Australian for those playing along at home, but today I want to give you a brief intro into IPFS and Filecoin and then dive into making an NFT and some of the uses for NFTs. They're not just JPEGs, so I want to dive into some of the uses for NFTs and then dive into how you would go about making one as well. And why IPFS and Filecoin are important in NFT creation as well. So firstly though, I want to clear up some of the names that you might have heard out there around Filecoin, Protocol Labs, IPFS. So firstly, Protocol Labs, which was founded in 2013, is a fully distributed open source research and development organisation, R&D organisation. It builds protocols, tools and services and aims to help radically improve the internet and drive breakthroughs in computing, which can help move us and humanity forward. So there's some really big goals there, and we really mean it when we talk about that vision. So we're really aiming for an open, inclusive web and to tackle some of the centralisation and censorship problems that have come up that mean that really our access to technology, or some people's access to technology, is limited, or their access to knowledge and research is limited. So we're really trying to build out some infrastructure to underpin this mission to open up knowledge, like that was the original goal of the internet as well. So IPFS and Filecoin are two projects that were originally incubated by Protocol Labs and now are their own separate projects. So I'll just note here that IPFS itself is a protocol, so it's not a blockchain, has nothing to do with blockchains, well, except in how you use it, but basically it's a kind of version of HTTP, so it's a protocol, not a blockchain. Filecoin, on the other hand, is a distributed or decentralized storage network, which does exist on a blockchain, but it's unique because it is aiming to be a real storage network, a distributed storage network, unlike some of the centralized storage networks we have today. So kind of like the Airbnb for storage. So now that we've cleared that up, I want to dig a little bit deeper. So I'm going to start with IPFS, or cue the Star Wars theme please, Interplanetary File System. So this isn't just a meme name, because as a distributed peer-to-peer network for files and folders, it was designed to be able to work even when the network is between planets. So let's say you signed up for the Mars Colony program and you're happily living on Mars now, maybe with Elon Musk. Let's say it takes you an hour or so to request a file from Earth that you need. But if someone else on Mars already has that file, then that person can just serve you that content instantly instead. So maybe you're thinking now, well, this just sounds like a fancy story for a peer-to-peer network, but there's a real gravity, get it, in what it does, because IPFS is actually distributed by design. It has no central authority servers. It's designed to be offline first for resilience, and it uses a really unique and upgradable standard for addressing content. So IPFS is unique because rather than using methods that we might be familiar with for storing and accessing content, so like we go to a location path on the web, we go to a URL, which is actually a location path that points at a particular HTTP address, and the content there could easily change. So someone could, buy that domain name and put new content there. So we're not guaranteed that if we go to a HTTP location address, we're going to get the same content back. It can change constantly. So instead of this location addressing, IPFS uses content addressing. So this means that you can be sure when you access an IPFS content ID that you'll get the exact same piece of content every time. And you also then don't need to care where that data comes from, which really opens it up to distributed storage solutions. So this idea was kind of wild to me when I first started looking into IPFS and Filecoin, because it's really a mind shift from the Web 2 world we're kind of all accustomed to. But it's super elegant in its simplicity as well. So just shifting the focus from that location-based address to a content-based ID really opens up the web to massively distributed storage solutions, to owning your own data as well. And these are some of the reasons for warnings, if you've dug into NFTs before, for warnings on ERC 721 templates or NFT implementation blogs. But I'll get into why there's warnings on those a bit later. So how does this work? Diving into the matrix here of how content addressing works. Basically, in order to create a content address, which you can kind of think of like a cryptographic fingerprint, we use a cryptographic hash function to create a content identifier, or CID for short. And we do that for each piece of information that we want to put on the network. So this means every piece of content has its own unique CID. If I say create a CID for a meme image or something, and then I go ahead and change one pixel of that meme image, that would mean the content ID, the CID for that image, has then changed as well. And just to quickly note here as well, this content addressing system works for all content, including folders or even full file structures and more. We've even saved snapshots of the whole of Wikipedia back in 2018 onto IPFS. So this is really compatible with all sorts of web work and other work out there. It's a really like an infrastructure, it's a protocol. So IPFS, super cool, dig into that some more if you're interested. The main thing to understand here is all this protocol and networking logic is important and valuable protocol, not just for Web3, but also tech use cases in general, and for anyone who wants to serve or retrieve content on the web, because it enables distribution at scale and it provides verifiability of the data that's being served. Now, we kind of come up against a problem the early internet also had, though, because there's no real permanence to this data. You either need to run your own nodes, which you can easily do on your laptop, by the way, but if you shut your laptop, then all of a sudden the content that you've got there isn't retrievable by anyone else because the node's not running. Maybe you would have your friend, maybe this piece of content that you're saving is super popular meme and everyone wants to store it, so it's easy to retrieve. But we all know from using kind of similar torrenting things that despite the good intentions of a community, less popular pieces of content usually stop getting hosted and they're no longer able to be retrieved. And we've all probably experienced this with, and we've all experienced this for sure. So obviously we also don't want to be then. There's another option, which is to pay a centralized pinning service. So these pinning services will guarantee that your content gets stored on their IPFS nodes and that you'll have like kind of an uptime of 99.99% or whatever it is. But the problem with this is then we're creating that centralization model that we were trying to avoid in the first place. So this is where Filecoin really comes in for you playing at home, as you probably guessed. So Filecoin is really designed to leverage crypto-economic incentives to keep this data distributed, reliable, verifiably stored, and also incredibly cheap. So it uses like cryptographic proofs and also enables smart contract-based permanence, and it means that it's designed to be as permanent as you, the data owner, want it to be. So there's lots of cool things about the Filecoin network if you do want to dig deeper into it, but the main thing to realize is this is how you can store either your IPFS or HTTP or any sort of data permanently and verifiably, and usually cheaper than you could find at any of the centralized services out there as well. So IPFS and Filecoin really fit together well, like gamers at a game hack, but IPFS isn't Filecoin, and so they're amazing complements because Filecoin really commoditizes storage, which IPFS needs in its awesome protocol network. So just as a side point, like I said earlier, IPFS is storage layer agnostic. That means you can combine it with the storage layer of your choice, which could be Filecoin, and we think that's a great option, but you can also store your data with data with a centralized cloud storage provider or any other decentralized storage solutions out there. So IPFS, storage layer agnostic. Okay, let's get to the section that we're all kind of interested in, or at least I hope, NFTs and why they matter. So NFTs have become a really big story in the last year or so. Celebrities, big brands everywhere releasing their own NFT collections, millions of dollars changing hands for them, and even auction houses like Sotheby's getting involved in auctioning NFTs. So tweets of code have even been sold as NFTs, and the Australian Open Tennis Tournament also released an NFT allowing people to own a piece of the action on the courts. There's even some real estate deals going through as NFTs. So really there's a lot of noise and hype going on in the NFT space when you start your NFT journey, and this can be really overwhelming, and because there are scams out there, which us in the industry do not like it, by the way, but because there's scams out there, sometimes it can be really hard to cut through the noise and understand why NFTs are important and why they have so much utility and the potential to really disrupt some industries, as we've kind of started to see with artist markets and giving control back to artists of their own work. Because an NFT can kind of be considered like a digital fingerprint, like you can verifiably prove that this NFT is your work or that it's owned by you. It's a signature or a computer authorization, some of those things. So firstly though, what does non-fungible actually mean? Because we're talking about NFTs, which is a non-fungible token. Is that part of the mushroom family? Is it fungulicious? I don't know. Just kidding. Obviously not. A non-fungible asset simply means that it's unique or it has a limited number associated with it. So unlike other assets like Bitcoin or money, where you can trade one Bitcoin or euro or US dollar for another Bitcoin or euro and have the exact same thing, NFTs are all one-of-a-kind assets. You can't just swap them out. So with an analogy more akin to trying to swap the Mona Lisa, which is a painting, for a girl with a pearl earring with another painting, they're just not equivalent. So this non-fungibility and their basis on blockchain gives NFTs some really essential properties. So it's important when we think about NFTs to not just think about the JPEG narrative. I can just copy and paste that NFT, so what's the big deal? NFTs are far more versatile than this Twitter bubble would maybe have you believe. So NFTs have really 6 main properties that open up a lot of opportunity for disruption and a bunch of use cases. By design, NFTs are unique, which we kind of mentioned earlier. It means it can represent a digital or physical product like a collectible, a house contract, a vote, or a ticket. They're provably scarce. NFTs have a traceable origin, which is backed by a cryptographic hash, with supply being controlled by the owner or developer, which has some great applications for, say, collections of gaming assets or for limited edition representation of items like signed albums or similar things. This could also be used for things like proof of education or attendance purposes. And this is already happening as well. So 3, they have a guaranteed ownership, which is a property that's inherited from the blockchain and which really ensures traceability and data verifiability of NFTs. So this gives rise to application usage for things like identity and authenticity purposes. They're also fraud resistance, which is another blockchain inherited trait. So because NFTs are secured with cryptographic proofs, they can be used in things like voting or membership rights, securing of identity or authenticity, and legal applications for both digital and physical things. And I know I'm an ex-IBMer, and I know IBM is currently using them to ensure the authenticity of patents as another example. So they're transferable as number 5. NFTs can be transferred, so they can have value inherently attached to them, giving rise to use cases in asset management or finance records, or many of the art and music industry applications that we're seeing currently, like giving royalties per play of song or per transfer. 6, they're indivisible. NFTs aren't divisible, meaning they can be used for things like fractional ownership purposes, for example in real estate, or other higher value assets like yachts. So some really interesting and unique properties to NFTs, and pun intended. It's these properties that really open up a really good opportunity for use cases and applications to be based on NFTs too. And these are the properties are really where I want to encourage you to start when you're thinking about new applications and use cases they could apply to, especially in gaming. So they could be super powerful for generating new kind of game economics or game models. Anyway, there's a heap of use cases around it. I've probably spoken too much already, but here's a list of things that NFTs could be great for, just off the top of my head. And we're already seeing a lot of these things come to be and to really disrupt industry as well. So check out some of the cool examples out there of NFTs doing good stuff. All right, so I could probably go on about this, but we're here for the code, so let's get into how we go about constructing an NFT. So the current standard for NFTs on Ethereum is called ERC 721. And by the way, ERC is just means a particular type of Ethereum application. So it's Ethereum request for comments, I think. I don't know why it's got that name. It really doesn't tie back to what it is. But anyway, that's what an ERC is. So while you could code up an NFT from scratch, a better approach is really to use a community vetted and security audited implementation of this standard. And you can find a lot of these templates on Zeppelin. So Zeppelin has a wide range of standard implementations and utility contracts, including ERC20 as well, which is like a token contract. Anyway, so you can find these on Zeppelin. There's already been vetted, they've already been audited, and they're widely used by the community to create NFTs and tokens on any Ethereum compatible chains like Nfts. So cool. Then what? All right, if we do have a look at the Open Zeppelin code base here, we can see the ERC 721 standard kind of comes with a few things: a constructor, we've got a token URI, we've got a safe mint and a mint function, and quite a few other functions there. But what all we really need for this, sorry, I'll just skip across. Let's have a look at the example that Open Zeppelin pastes on their site, actually. So here's an example of implementing this ERC 721 contract. And this contract is called a game item, but this is really just creating an NFT, sorry. So game item is ERC 721 URI storage. Don't worry about that for now. And then the constructor just uses that ERC 721 contract and takes in a name and a symbol. So the game item string is the name of this collection of NFTs, and the ITM here is the symbol for this collection of NFTs. And then it has a function called award item. So this is really where they're minting the NFT. So it takes in the address of a player. So that would be an EVM address, so a MetaMask, for example, address. And then it takes in a string memory token URI. And then all it does is creates a token ID. So each one of your NFTs will need a unique ID, much like you do in a database. You need to know which one's which. So you're creating a whole collection, could be 10,000, a million, could just be 100, could just be 2, but you need to have a token ID in order to identify which NFT it is. So this is what this token IDs.increment function is doing here. So it gets the current token ID that we're up to, and then it mints an NFT. Just calls mint with the player address and the token ID, new item ID, and then it sets the token URI, which we haven't spoken about yet, to for that token ID to this token URI. All right. So what exactly is this token URI though? Is the question. Well, it turns out that this token URI is really just a JSON format. So it's a JSON document that might look something like this: name, description, image, and then say a bunch of attributes like strength or several other things. And I think Erica spoke about this JSON file as well in his Unity demo with Nfts.Storage, which I saw and was totally awesome, by the way. But anyway, so this is just a JSON file. We've all seen a JSON file before. So key value pairs in an object. That's all it is. Now the thing is here, they've got an image which has a HTTP address. And if you remember earlier, I was talking about how, location-based addressing means that the content at that address might change. Now, if you think about it, this could be a problem for a non-fungible token, right? We really don't want whatever metadata we're attaching to this non-fungible token to be fungible, to be mutable. So even Open Zeppelin themselves mentions that this is a bad way to do it. So you shouldn't be doing this. Either you're passing the data directly into the contract, or you should be using something like IPFS, a content addressing and immutable content address standard to create it. And this is some examples of what happens when you don't, or when NFTs collections have been released with these kind of HTTP location-based addresses. So the first one here sold an NFT collection with a bunch of art, as you can see up the top there. And then a few weeks later, after he'd sold out of this collection, he deliberately changed the content related to that image address into actual rugs, turning into a rug pull. There was another one here called F Bubbles, which basically used his collection of NFTs to then advertise his next collection of NFTs. So he changed the message on this Bubbles NFT to whatever his next drop was going to be and used it for advertising. So both of these things are not ideal and not something that we really want in our NFTs. So that's why you use IPFS basically, and I'll quickly talk about this since it's in my slides here. So there's a newer NFT kind of contract out. It's actually a multi-token contract, and it's called the ERC 1155. And this contract's interesting because not only does it enable you to mint NFTs, but it also enables you to do tokens. So you could do both tokens and NFTs all in one contract, which is pretty exciting for things like gaming, because some assets you want to be non-fungible. So maybe you've got a special sword that shouldn't be, isn't something that every character should have, and that should be an NFT. But then maybe you've got in-game money, and that is fungible. You should be able to swap that. So this is a really exciting token standard, particularly when you relate it to gaming. And it's fairly similar to the ERC 721 contract with a few, extra additions, obviously, because you need to be able to, because you're creating two different kind of tokens in the one contract. Alrighty, so the too long didn't read of that big section there for IPFS and Filecoin. IPFS, which is a protocol for Web3, uses content IDs to create cryptographic hashes and allows peer-to-peer data transfer. Filecoin is the incentivized persistent storage blockchain and protocol, which is great for large data. So why do we need these for NFTs? Because for NFTs, we need storage that's off-chain. If you are storing data on-chain, and you totally can do that, it's another safe way to do it, but it generally gets prohibitively expensive, or you're going to have particularly large files on-chain, or you have to change them a lot. All of these problems are solved if you use something like IPFS and use off-chain storage. Then you need a fixed address, which I mentioned. You need an IPFS CID, and you need storage that's persistent and reliable, which is where Filecoin comes in. Alrighty, so I'm going to now play around with creating an ERC 721 and an ERC 1155 contract in Remix, which is basically an online editor that you can use to test your contracts. So dynamically minting the NFT, so I'm kind of creating a dynamically minted NFT, which just means that we aren't really creating or minting the NFT until the contract function is called. So this could be called by the front end of a website or from game logic when a player signs up, levels up, finds a secret door, or whatever else there might be there. And so bear in mind that this function is public, and so anyone can actually call it with any data, so you wouldn't really want that in your game. Instead, you'd want to set a base URL for your image and set the item image in your constructor, or only allow verified players to mint this NFT, or keep a list of verified players. Or you could batch mint a certain number of NFTs before the game as well and have them available to hand out when this event is triggered in the game, for example, whenever you want to hand out the NFT. Okay, so let's have a look at this ERC 721 contract on Remix. And this is a really basic implementation, much like you saw with the Open Zeppelin example. This is what it looks like on Remix, and I will actually open up my Remix and show you that as well. Okay, so I've just navigated to Remix, so remix.ethereum.org, and like I said before, this is really just a Solidity IDE online. So you can do code online with GitHub now. It's a similar thing. This will compile your Solidity code, which is one of Ethereum's main languages, down and check on it as well. So basically all I've done here is exactly like the example. I've imported those Open Zeppelin contracts up the top here, and I'm also just using a helper from another tool called Hardhat to console log, because you can't inherently do that with Solidity. So I'm using a tool from another provider, a plugin, in order to be able to console log a few things here. So when you open this up, you will get this default workspace, and so I've just created this contract under the contracts, and I've created quite a few of them so I can show you. And this is the NFT basic so feel good NFT 721 basic .sol.solidity contract here. Like I said, I've imported those contracts, and then here's my contract. I'm naming it Feel Good NFT 721 Basic is ERC 721 Uri Storage. Now, don't worry about that. That's kind of just an extension to the ERC 721 contract, which just makes it a little bit easier for me to show it to you with the IPFS URI that you want to put in for the metadata of your token. Like you can see, it's fairly simple code, just a constructor here which gives it a name, and then that symbol that I was talking about earlier, all I've done is console log out that gets created, and then I've got a function called mint_my_NFT which takes in this IPFS URI, so the CID of that JSON file that I want to use. And then it returns the UN 256, which is just the token ID of that token. So like I said earlier, this is the token ID's counter, which I've also imported there. And then I safe mint it with the message sender. So whoever calls this function will be the sender. And that will be their address, and that's who this NFT will belong to. And then there's the token ID, which we spoke about. That's the identifier for this collection of NFTs, of that particular NFT. And then I set the token URI to be that IPFS URI. And then increment the tokens, and that's really all there is to the basic contract. Let's say, though, I kind of wanted to do something a bit more exciting. So with my contract, maybe I want to say limit, the number of NFTs that I want to have in this collection. Let's say I only want 100, or let's say I only want to allow one NFT to be minted per user, or per wallet really. Then we can add a few things. We can add a couple of variables to this contract, so max NFTs, and then also a mapping for, this is a key value mapping for owns NFT to give us an idea of that. And then we can implement these. So in the constructor, I'd set this max number of NFTs to 100. And then, just go back a slide, sorry. And then when in the mint my NFT function, I would check firstly that the person calling the function doesn't already have one of these NFTs, and if they do, I wouldn't execute. And I would secondly check that we haven't already minted the max token of NFTs, so there's still some NFTs available to be minted. And then when a user does mint an NFT, I would add the address of that user to my owns NFT function. So all fairly simple, fairly, I don't like the word simple because, sometimes it never is, especially if you're learning, it can seem quite difficult. But this is all fairly easy to follow code, hopefully, for you. So, so that's really all you would do. And I have a function that does exactly, or I have a contract that's doing exactly this, which I will just try and find anyway. If I can find if I can find the desktop that has that on it, hopefully I can. Where is it, God? Nope, that's not the one. It's definitely on my desktop here. Apologies for that. Oh, here it is. I found it. Great. Okay, so let's go to the contract that has this in it. So you can see here I've got a variable, and it's also got sorry, it's actually not that one. It's this one here. My apologies. Okay, so you can see here I've added the max NFTs and the owns NFT functionality like we just walked through, and the require function. Okay, great. So I've got a bunch of these contracts. How do I deploy it? You're probably wondering. I just want to deploy this to chain. And I know you've got the Godwoken chain on Nfts, so please make sure that you set up your environment in order to be able to deploy for that. And you will need a wallet that interacts with Ethereum. So I'm using MetaMask. And I'm pretty sure you can use MetaMask as well for Nfts. So you'll just need to add the network for that. But at the moment, I'm just using a test network called Rinkeby, which is actually getting decommissioned soon, so probably don't rely on that too heavily. It's just that I happen to have quite a bit of testnet ETH on this network, so I'm using it. But you could use any ETH compatible wallet. So for example, you could use a Polygon network, Godwoken network, which I hope is a good choice here. The Kovan testnet as well, which is another Ethereum testnet. And Girly is another Ethereum one as well, so plenty of options. You can even use the Binance Smart Chain that's also EVM compatible. So how do you deploy this? The first thing you want to do is check that this contract compiles. So you'll go to the tabs down the side here. You've got like your files here, then a search function, and then you've got the compile tab. It's not too obvious that that's a compile tab, but that's what it is. And then you can hit the compile button and make sure that your contract that you're looking for, so this is not the right one. I'm actually wanting to do the Feel Good NFT 721 Basic Limited Edition only one contract here. So I'll just switch to that and then I'll press compile. And by the way, you'll notice there's a button here called Publish on IPFS. So you can publish these contracts to IPFS right from within Remix as well, keeping this code always immutable. Alrighty, great. So that's compiling fine, and then let's just go and check out our deployment options. So that's the compile, and then the button below that is our deployment, and hopefully you can see that okay on the screen here. So I'm using injected Web3. So there's some test wallets that you don't need, test wallets that are built into Remix here that you could use, but I'm going to use my MetaMask account for this one. So to do that, you use the injected Web3 network, and that's what you would use for the Godwoken network on Nervos as well. So just change to that one, make sure you have MetaMask installed, make sure you have the Godwoken network on your wallet, and you'll be able to do this too. Now I'm just going to search again for the contract because this is that's the wrong one. So I'm going to look for the Feel Good NFT 721 Basic Limited Edition, only one contract. I'm getting good at that. And then I'm going to hit a deploy with my wallet on the network I want to deploy it to. So I'm going to click the deploy button here, and you'll see my wallet asks me to confirm that. So it's going to cost me a certain amount of gas in order to deploy that to the Ethereum network. I believe it's free on Godwoken, so even better. So I'm just going to confirm that transaction. And if we have a look down here, we also get some, idea on what is happening here. So it's creating the Feel Good NFT contract right now, and there we go, it's just finalized. And we know it's finalized because we can have a look down here at our deployed contracts, and if I just scroll down, I can see all the functions that come with this deployed contract. Now this is weird, right? I've got all these functions and variables, but I really only put a few in. There's only one function, for example, I only put mint my NFT in, but I've got all these other ones like approve, safe transfer, set approval, transfer from. I've got some getter functions as well, so these are all the kind of put functions. And then I've got getter functions here, balance of, get approved, max NFTs, which I did put in, name, which we did see in the contract. Let's see if that comes back as the same thing. There we go, it does. Symbol comes back as Filecoin starter NFTs. Not a very good symbol, but anyway, it comes back the right way, as it should. Max NFTs, we've set that to 100, so that's correct. So where are these extra functions coming from? They're coming from the underlying Open Zeppelin template. So let's try and mint an NFT, and I'm just going to find an IPFS URI, which I'm going to grab from Nft.Storage actually, because I've got a bunch of files already stored there. So I'm just going to quickly log into Nft.Storage and grab one of my old CIDs and use that as my minter. Ideally, you'd create this elsewhere, so you'd create your JSON file and then perhaps save it to Web3.Storage or Nft.Storage, and then you would use that CID. Because I'm just trying to do a demo and it's taking its time to load, I'm just going to try and get one of the files that I've already uploaded to Nft.Storage, get one of my CIDs, and I'm going to use that for my mint my NFT function. So let's call that function now. You see the wallet asks to approve it, and that's because I need to pay gas to mint this NFT. I need to pay for the token, which is actually free. The base price is 0 here, but I need to pay gas to actually mint this and have it confirmed on the blockchain. So I'm going to do that now, mint my NFT. And we'll see down the bottom here in the console log that it should hopefully mint. And then if I want to actually confirm that this is minted, I can go ahead and have a look at this transaction on Etherscan or another block explorer if you're using Godwoken. Or I can have a look here at owner of token. So that was the first NFT. So the first ID is going to be 0. So if I test this and see who the owner of the 0 token is, we get an address back, which is awesome. If I put in, and the address is actually a match to my MetaMask wallet, pretty hard to see there, but it actually is a match to my MetaMask wallet. If I put in token 1, which hasn't been minted yet, we'll see that it comes back with an error down the bottom here. So there is no token 1, so I can't get the owner of it, basically. So hopefully that's kind of, I don't want to go on too long there, so hopefully that's kind of given you a good idea of how you could deploy this. So you've actually, the last thing actually I will say is that you can, this wallet address, which, this should be a wallet address here. I think this is a wallet address. Let's go to Etherscan and have a look. So I'm just going to copy that. So I basically press the copy button here next to the name of this token, and that's given me an address which looks like this. And I'm just going to paste it into Etherscan, which is the block explorer for Ethereum, but I'm sure Nervos Network has their own block explorer as well. And you can see two things have happened on this block explorer. The first one was contract creation. I'll just zoom in a little bit on that. So contract creation here. And the second one is mint my NFT. That function was called. So there's two transactions on the blockchain, always going to be there. Like anyone can see them and verify that this has actually occurred and is the right contract. Yep. Beautiful. So I think that's probably about all I'll say about how to deploy a contract. I was going to go through an example with 1155 quickly. Maybe I will just show you the 1155 example as well quickly, because that might be something of interest to you. So the 1155 contract, let me just switch to it here. And I'm just going to trash this last deployed contract so we don't get confused. So the 1155 contract is a little bit different. So you can take these examples. These are all on GitHub. You can go and grab these examples for yourself and use them as well. Now, the difference with the 1155 contract is only that, unfortunately, you don't get a built-in setting token URI kind of function with the 1155 contract yet. So you kind of have to override the parent URI function that comes with the contract. And I've done this here in order to set the IPFS URI for this contract. As I said, I've got all these contracts online on my GitHub, and I will hand out that link at the end of this, so you can go and check out how I've done that if you want to have a further look into it. But again, same thing. I can compile it on Remix, I can deploy it on Remix, and then I can use it from my front end or from my game with some, connector code as well. So yeah, I can go and have a look here and deploy my Feel Good NFT 1155 basic. Here it is. So I can go and deploy it. It asks for my MetaMask confirmation to pay the gas. This is all testnet, so it's like also test tokens, which cost nothing. But yeah, so I think what happened there? It looks like it's still deploying. Anyway, basic same process, just with a little bit of fussing around in order to change to that IPFS URI in this contract itself. We also, if you notice, get quite a few less kind of functions with it. But the great thing about the 1155 contract is not just that it's multi-token, but it also has a lot of gas optimizations, and that's because of the way it's storing memory in the background. So if you are creating like 1 million NFTs, you want to have those gas optimizations built into your contract. So 1155 does that, and it also enables batch minting. So you can mint like a whole batch of like that million lot of NFTs all at once, is the other like kind of optimization for the 1155 contract. Alrighty, I think I've spoken about that one. Great. So, yep. I've spoken about the 1155 contract on Remix, and there's, caution, this contract requires us to override the URI function in the template in order to change the same functionality though. But yeah, there's the optimizations I just spoke about as well. Now, the other thing, that I did want to show you is an NFT project example. And it looks like this, and I did build this for another hackathon, which is why it says the graph feel good NFTs. But I've built an entire project that basically you can mint tokens on and play around with. On Solidity, it uses Nft.Storage, which we haven't actually spoken about yet, but Nft.Storage, it uses IPFS and Filecoin under the hood, but it makes it really easy to do. So that's how I'm creating those IPFS URIs. And it has two contracts in it. It has an ERC 721 contract, and it also has the ERC 1155 contract, which I've just spoken about. Now, here's a couple of the functions with creating NFT metadata with Nft.Storage from JavaScript. I use React here. So if you want to have a look into them, again, I'll give you the link to this project and also to the slides, and you can take a look at them for yourself as well. But it's as easy as, creating a new NFT storage client and then calling client.store. It's as easy as that to create Nft.Storage. And that creates the IPFS immutable CID and then makes Filecoin storage deals to store that permanently as well for you. So we can see it in action, and I do actually have this in action and up, so I'll just switch to that screen for you. We're not going to go to the... I'll just switch to that screen. So this is actually the project working and in action here. So I think it was bit.ly graph NFT URL. I will hand out that link after this as well. So I need to connect it to a wallet first. I just cancel that because I actually want to be on the Rinkeby testnet. So I'll leave it on the Rinkeby testnet. I need to connect to my wallet to use this. So I'm just going to click yes to connect to my wallet. Now I'm going to put my name in. Let's put Nervos in here, and I'm going to click mint my NFT. Now this is built, like I said, on a React front end and with those exact same contracts that we just went through. And this is showing it in action in the browser. So it's workable from your game logic as well. I'm not a Unity dev, but Eric can probably help you out with that. But yeah, I know he's got a wrapper around that as well. So similar kind of concept. This is the web version. If you do want to have a look at this and you think it could be helpful, please go and have a look at this project. So it's just taking quite a while. So I might just skip back to having a look at some of the slides to finalize this. I don't know what's going on here. It's been a while since I played with this one. So let's go back to the slides and having a look at what else I've got on the agenda to finalize this talk for you. Alrighty, so DevTools. I just wanted to go through DevTools. We briefly touched on Nft.Storage, and I know Eric from Nervous has also created a wrapper to use this with Unity. So go ahead and look at that. It's super easy to use. It creates that IPFS CID of data that can be that ensures that your NFT is immutable, and then it also stores that permanently. So it uses Filecoin to store that persistently with 8 times redundancy as well. I've also got for that demo I was just showing you, there's quite a few YouTubes out there of me going through that demo as well. The second thing, other tooling that we've got is Fleek. So Fleek can host your front-end static websites on IPFS, which is super cool. So check out Fleek if you want to host a front-end app that you have to Fleek using IPFS, so making it more decentralized and kind of resilient as well. The other one, what if I want to store things that aren't just NFTs? Well, we've got Web3.Storage designed for that, just as easy to use as Nft.Storage. And again, creating that IPFS CID for you and then storing it on Filecoin with redundancies, so 6+ Filecoin providers redundancy. And this is for anything that really isn't just NFT metadata. Last thing I want to say is more resources. Whatever you want to learn more, please go and have a look at proto.school for tutorials around IPFS and Filecoin use. There's nftschool.dev if you do want to dive deep into the world of NFTs and how they can be used, and some different functionalities and tutorials around that there. We've also obviously got our docs if you're interested in our projects and protocols, and our YouTube. If you do want to contribute, or you've got a project that you're looking maybe for some funding for that uses IPFS and Filecoin, go to hackathons.filecoin.io, check out some of the hackathons that we're in. That's the first way to get involved. And the second way is we do have a bunch of grants, so micro grants and kind of an accelerator program after that, with bigger and bounties and grants after that. And all of our GitHub repos are open as well, so you can check out what projects we're building in that space, and maybe you've got some skills that would complement some of those things that are happening in that space. So there's open bounties on many of those projects as well. Oh, wow. It looks like, okay. It looks like my token finally just decided to work. So maybe I'll switch back to having a look at that. There we go. So I might have a slow internet connection, I think. But yeah, so there we go. It proves it did work. So it just created that IPFS image link here. And you can go and have a look at that IPFS image link online as well. You can see a bunch of, maybe you can see, it's a bit small, a bunch of characters here, but you can see that this says Nervos on it. So this NFT has been created to say specifically whatever I input on the front end on it. So this was the success, and I've also created an NFT. So the NFT's been minted. Awesome. And we can see the last NFTs that were minted on this project as well down the bottom here. So I'm just using a function in my contract to call back the last 5 NFTs that were minted on this contract as well. And you can also see that there's only 88 more NFTs that can be minted before we kind of run out of space there. So cool. I'm glad that did go through and you got to see it. Alrighty, back to getting in touch or being involved. Well, you're already involved because you're already part of a hackathon, so congratulations to you. Honestly, I think that's awesome. I participated in hackathons early on in my career, and that's one of the best things I ever did. Not only did I learn and maybe win a few prizes and meet along the way, but I met some amazing friends, and it was actually the catalyst for me even becoming a developer advocate, because someone I met at a hackathon rang me up with a job opportunity about 6 years later. So you just never know where hackathons can take you. So kudos to you. You can also become your own startup, or you're being your founder from hackathons, like building out that project. You're kind of testing the idea along the way. I've seen quite a few people go along that path as well, so you just never know where they can take you. Anyway, if you do want to see more from us, we have the weekly Gather Town. We also have a job board up there, and otherwise it's been a great pleasure hanging out with you all here at Game Jam, and yeah, get involved, as I already said, hackathons.filecoin.io. See some of the projects that have been built on IPFS and Filecoin there as well. So there's a bunch of other projects using our tooling as well. So LivePeer, which is a live streaming app, uses IPFS and Filecoin. OpenSea, which is an NFT marketplace, uses Nft.Storage under the hood when they're minting NFTs. There's a few little games out there as well. One of them is Tetris, which basically takes each move from your Tetris game, decentralized Tetris, from your Tetris game, and saves that as an IPFS CID, and then it puts it all back together and creates an NFT out of that. And if you go and view that NFT, it's actually the whole game playing. So kind of a really cute concept for gaming around IPFS and NFTs. And another one was this pixel art, which used IPFS to create a pixel image and then create an NFT of it as well. So lots of kind of fun things you can do. Oh, and one more thing I'll say is never forget this.xyz, NFT, never forget this, .xyz is also like the film version of NFTs, and they have some really cool stuff and explainers around what NFTs are as well, so check that out. And with that, learn long, build and prosper. Thank you everyone for listening. Hopefully you learned something. Hopefully I'm sure I'm going to see some really cool projects come out of BlockJam, and I appreciate you listening. Thank you.